Welcome to another lesson in General Mathematics. In this lesson, you will learn how to find the domain and the range of rational functions. Before we begin, let's have first a short review. Recall that domain is the set of first coordinates or the x values of the ordered pair. For example, if we have the following ordered pairs, 0, 1, negative 2 and 3, 3, negative 1, 4, and 5, the x values are 0, negative 2, 3, and 4. Therefore, we can conclude that the domain includes 0, negative 2, 3, and 4. So notice that these are the first coordinates in the ordered pairs in the given example. While the range is the set of second coordinates or the y values of the ordered pair. From our previous example, we can identify the y values, which are 1, 3, negative 1, and 5. Therefore, we can conclude that the range includes 1, 3, negative 1, and 5. Notice that these values are the second coordinates in the ordered pairs from the given example. We also have the term real number, and it is represented by this symbol. So what is a real number? A real number is a number that includes rational numbers such as your fractions, 3/5, for example. We also have decimal numbers, or 35, we have here 35 hundredths. We also have repeating decimals. We also have integers as a real number, such as negative 2, negative 1, 0, 1, and 2, and so on. We also have whole numbers that include 0, 1, 2, 3, and so on. Natural numbers, or your counting numbers, such as 1, 2, 3, and so on. We also have irrational numbers, such as pi, square root of 2, negative square root of 3. For example, your real numbers are negative 2, which is an integer, 1/2, which is a rational number, positive 3, which is a whole number or a natural number. It can also be an integer. 0, which is an integer or a whole number. And we also have the repeating decimal. And of course, a decimal, which is a rational number. So these are examples of a real number. Now, let's begin on how to find the domain and the range of a rational function. For example, we have here a given function, f of x is equal to 2x divided by x minus 2. We're going to find the domain and the range of these rational functions. First, we're going to find the domain of the rational function. So how do we find the domain of a rational function? So we will look for the value of x in the denominator that will make the function undefined. So in our given function, the denominator here is x minus 2. So in order for us to find the value of x in the denominator that will make the function undefined, we will equate this denominator to 0. So we have a new equation, x minus 2, which is equal to 0, in order for us to look for the value of x that will make the function undefined. So to do this, to solve for x, we need to eliminate this negative 2. How do we eliminate this negative 2? The shortcut way here is by transferring negative 2 to the right side. To the right side of the equation. So, it will become x is equal to positive 2. So, kapag inilipat natin ang isang value sa kabilang side, nag-iiba na ang kanyang sign. So, if it is negative here, it will become positive on the right side. Therefore, the value of x that will make the equation here, or the denominator here, equal to 0 is positive 2. And this will make our function undefined. And it is not included in the domain. Take note, if that value of x will make our function undefined, it is not included in the domain. So therefore, we can state that the domain is the set of x, all values of x, the set of all real numbers except for positive 2. So we can read this set builder notation as x is the set of all real numbers except 2. Bakit hindi kasama ang 2? Because again, 2, positive 2 will make our denominator x minus 2 equal to 0. And take note, remember that if the denominator of the rational function is equal to 0, it is undefined and it is not included in the domain. That is why our domain here is x is the set of all real numbers except for positive 2. How about the range? How do we find the range of a rational function? So first, we're going to change f of x to y and solve for x. Since we have here the given function, we have to change f of x to y, since we are finding or looking for range, which are the y values. Simply copy this expression, 2x divided by x minus 2. The next step is we have to solve for x. To solve for x, we have to use the shortcut. Using the butterfly method, we have to multiply y to the denominator x minus 2. So it will become y times the quantity of x minus 2, and simply copy equals 2x. Next, we have to simplify this part of the equation using the distribution property of multiplication. So we have y times x, and that is xy. So in writing the variables, simply follow the correct order in the alphabet. So that is why we have here xy. Next, we have y times negative 2, and that is negative 2y. And simply copy equals 2x. Next, since we are looking for the value of x, we have to identify the terms having the variable x. Since 2x contains x, we have to combine it with the variable xy. So pagsamahin lamang ang mga terms na merong x. Since ang 2x ay nasa kanan, kailangan natin siyang ilipat sa kabilang side para magkasama sila ng xy. So, and that will become xy minus 2x since it is positive on the right side. Again, kapag inililipat natin, if we are transferring terms or values on the left side or right side, the sign will be changed to its opposite sign. Next, anong gagawin natin sa negative 2y? Since wala siyang kasamang x, ililipat natin siya sa kabilang side. And it will become positive 2y. Since it is negative on the left side, it will become positive on the right side. Next, we have to simplify this part because meron siyang common factor, and that is, the common factor is x. So, kapag may common factor, isusulat natin ang common factor. Then, we have to divide the factor in each term, like xy divided by x. Simply cancel x, and the remaining is y. 2x divided by x. So, cancel x. Since common ang x, the remaining is 2. Therefore, we have y minus 2. Or simply, you can use the shortcut. Since nailabas natin ng x, factor out ang x, natitira ay y. So, we have here y. Nailabas natin, common factor is x. So, natitira dito ay 2. Okay, that is another way of factoring this part of the equation. And simply copy positive 2y. So we will continue this in this side since we have x times the quantity of y minus 2 equals to y. Since we're looking for the value of x, kailangan natin ma-eliminate ang y minus 2. How do we do that? So simply divide the whole equation to y minus 2. So again, this if it is divided all over, if the factor is divided in the whole equation, y minus 2 is divided on the left side and also on the right side. So here, we can cancel out by dividing. We can cancel out since it is a common factor. We can cancel out y minus 2, and the remaining factor here is x. So we can write x, and that is equal to 2y, which is divided by y minus 2. Okay, so this is now the value of x. So from our previous solution, we have found the value of x, which is 2y divided by y minus 2. So how do we find the range in this given equation? Simply equate the denominator to 0, like what we did with the domain, for us to look for the value of x that will make the function undefined. So we have y minus 2, and that is equal to 0. For us to find the value of y, we need to eliminate negative 2. So to do that, we will use the shortcut method. We have to transfer negative 2 on the right side, and that will become positive 2. So therefore, your y is equal to positive 2. Therefore, we can say that when y is equal to positive 2, meaning if we substitute the value of 2 here, 2 minus 2 is equal to 0, and if the denominator is 0, the function will be undefined. And that positive 2 is not included in the range. Take note, if that value will make the function undefined, it is not included in the range. Therefore, we can say that our range is y is the set of all real numbers except positive 2. Again, because positive 2 will make our function undefined. So, other than 2, all real numbers are the solution to our rational function, or values of range in our rational function. Therefore, we can conclude that the domain and the range of this rational function are the following. So it is written in this set builder notation. Next, we have example number 2. Find the domain and range of the rational function f of x is equal to x minus 1 divided by x plus 4. First, we will look for the domain of the given rational function. So how do we do that? First, we have to look for the value of x in the denominator that will make the function undefined. So if this is the given rational function, we have to identify the denominator. And the denominator is x plus 4. So we will equate this to 0 for us to find the value of x that will make the function undefined. So we have x plus 4, which is equal to 0. We will look for the value of x, and we need to eliminate positive 4 for us to look for the value of x. So to do that, we will use the shortcut method by simply transferring positive 4 to the right side, and it will become x, which is equal to negative 4. Since this is positive on the left side, it will become negative on the right side. Therefore, the value of x is negative 4, and if we will substitute negative 4 in x, here in our denominator, negative 4 plus 4 is equal to 0. Therefore, negative 4 is not included in the domain since it will make the denominator equal to 0, and definitely it will be undefined. Remember, if the denominator is 0, it is undefined and it is not included in the solution. Therefore, we can conclude that the domain of this rational function is x is the set of all real numbers except -4, because -4 will make the function undefined. So again, the domain of this rational function are all real numbers except for -4, and it is written in the set builder notation. This time we will look for the values of the range. To do that, simply follow the steps. If we have this rational function, first step is change f of x to y, since we're looking for range or the y values, and copy this given expression. Next, we will solve for x. To do that, we will follow the shortcut method. Multiply y to the denominator x plus 4, and it will become y times the quantity of x plus 4, and simply copy equals x minus 1. Next, we have to simplify this part of the equation using the distribution property of multiplication. To do that, simply multiply y times x, and that is xy, y times positive 4, and that is positive 4y. Simply copy equals x minus 1. Next, we have to, since we're looking for the value of x, we have to transfer positive x on the left side so that we can solve for the value of x together with xy. So to do that, we have here xy minus x. Since x is positive on the right side, it will become negative x on the left side. Next, we have to transfer positive 4y on the right side because it doesn't have the value of x, and it should not be on this side since we're solving for x. So to do that, we have this value negative 4y since it is positive on this side. We have negative 4y and simply copy minus 1. Next, we have to simplify this part of the equation since it has this common factor x. So we have to factor out. The common factor is x. So we have to write x and divide x on each term. Xy divided by x is y. X divided by x is 1. Simply copy minus sign or subtraction sign. Therefore, we have here x times the quantity of y minus 1. If we will try to multiply x, distribute x to y and negative 1 by using multiplication, it will go back to its original product, or xy minus x. Since x times y is xy, x times negative 1 is negative x. And simply copy minus 4y minus 1, or negative 4y minus 1. So to continue, we have here, since we have x times the quantity of y minus 1, which is equal to negative 4y minus 1, we have to eliminate y minus 1 since we're looking for the value of x. So to do that, divide the whole equation by y minus 1, meaning we have to divide y minus 1 to the right side and on the left side. Next, we have to eliminate y minus 1 since it is a common factor. The remaining factor here is x, so simply write down x and on write down equal sign, and we have on this side negative 4y minus 1 divided by y minus 1. Therefore, the value of x is given on this equation. Since we have found the value of x, we can now solve or identify the value of the range. To do that, we have to equate the denominator to 0 for us to identify the value of y that will make the function undefined. So we have y minus 1 is equal to 0. Since we need to solve for y, we have to eliminate negative 1 by simply adding plus 1 or simply transferring negative 1 to the right side of the equation. Therefore, we have y which is equal to positive 1. Therefore, when y is equal to 1, the function will be undefined. So if we substitute 1 to y here, that will become 1 minus 1, and that is equal to 0. Since the denominator is 0, if the value is 1, therefore 1 is not included in the range. Therefore, we can conclude that the range is y is the set of all real numbers except positive 1, and it is written in this set builder notation. Therefore, we can conclude that the domain and the range of the rational function are the following, and it is written in the set builder notation. Next, we have here an example with a rational function with a denominator of 1, that is f of x, which is equal to x squared. Since our rational function doesn't have a value of x in the denominator, we can conclude that the domain is the set of all real numbers. Ibig sabihin, lahat ng values ng x na real number ay pwede sa ating rational function if we are talking about its domain. This time, we will look for range of our rational function. To do that, simply change f of x to y, copy equals x squared. Since we only have a variable x here, we will solve for x. But our x squared contains an exponent of positive 2. We need to eliminate the exponent of 2 for us to solve for the value of x. To do that, simply get the square root of x squared for us to cancel out. So we can cancel out the exponent of 2 in the radical symbol. So that is the easiest way on how to cancel the exponent of 2 by getting its square root. So if we do that on the right side, we also do that on the left side. Therefore, since we have cancelled out both the exponent and the radical symbol, the value of x is the square root of y. Therefore, from this value of x, we can identify the range as y is the set of real numbers, of all real numbers, such that this bar is read as such that y is greater than or equal to 0. Take note, if it is greater than or equal to 0, we have the values of y as positive values, because positive values are greater than 0, and that includes 0. Why negative numbers are not included here? Because negative numbers doesn't have square root. So we can only get the square root of positive or negative, positive values and 0. Next, we have here the next example. We have the given rational function f of x, which is equal to 3x minus 2. Notice that the given rational function doesn't have a value, or it doesn't have x in the denominator, because if you look at it, it doesn't have a denominator except for 1. That will make the function undefined. So therefore, we can conclude that the domain is the set of all real numbers, and that it is written in the set builder notation. Next, we have to find the range. To do that, simply change f of x to y and copy 3x minus 2. Next, we have to solve for x. Since we only have one term here with x, which is 3x, and it is already positive, we have to retain 3x on this side. And simply transfer negative 2 on the left side of the equation. Therefore, we have y plus 2, simply copy 3x. Since we are looking for x, we need to eliminate positive 3. So to do that, we will divide 3x by 3. So we can cancel out both positive 3. And we also divide the left side of the equation by 3. Therefore, the resulting equation would be, since 3x divided by 3 is equal to x, copy equal sign, and copy this part of the equation. Or we can have x, which is equal to y plus 2 divided by 3. Since we have now the value of x, we can find the range of our rational function. Since our denominator doesn't have y value, since our positive 3 ay walang kasamang y, therefore, our rational function is not undefined in any value of y since wala siyang y na kasama. Therefore, we can conclude that the range is y is the set of all real numbers. So, lahat ng real numbers ay pwede as a value of y. Therefore, from our previous solutions, we can conclude that the domain and the range of our rational function is written in this form, and they are set of all real numbers. Next, we have this rational function f of x is equal to 1 divided by x. First, we have to find the domain. I know you are already familiar how to find the domain since we are now on the 5th example. So to find the domain, we will equate our denominator to 0 so that we can identify the value of x that will make the function undefined. So to do that, we already have the value of x which is equal to 0. Since there is only x in the denominator. Therefore, x is equal to 0. Therefore, this value, which is 0, is not included in the domain because it will make our rational function undefined. Therefore, we can conclude that our domain is the set of all real numbers except for 0 because it will make our function undefined. Next is the range. To do that, to find our range or to look for the range, we have to change our f of x to y and simply copy 1 divided by x. Then we have to solve for x. To do that, simply multiply y by the denominator x. So y times x is equal to xy. Simply copy 1. Next, we have to solve for x. Therefore, we have to eliminate y. To do that, simply divide xy by y for us to eliminate y since they are common. Next, we also divide 1 by y. So the resulting equation here is we already have the value of x which is equal to 1 divided by xy. Since we already have the value of x, we can identify the range. And to identify the range, we have to equate our denominator to 0 for us to identify the value of y that will make our function undefined. Since there is only y in the denominator, we can already have the value of y which is equal to 0. Therefore, 0 is not included in the range. We can conclude that the value of range or our range is the set of all real numbers except 0. So from our previous solutions, we can conclude that the following are the domain and the range of this given rational function.